We're at Vandenberg Air Force Base. We're about 20 minutes before the launch of ICESat-2. You might see the white light off in the distance. That's the Delta II rocket.
It kind of feels like an idea that was always going to just stay an idea. But no, it's real. It's sitting on top of the rocket.
You know, and for me, it's kind of surreal. Like you say, it's been 10 years, and it's hard to believe. It's like, we're really here? This is really about to happen? It's totally cool.
This is Dr. Tom Newman. Over the years, his work has taken him to some pretty remote areas to study changes in the ice regions of our planet. And his research, among many others, has defined the goals of the new NASA satellite, the Ice, Cloud, and Land Elevation Satellite 2, or ICESat-2.
And we have ignition. And
the story of ICESat-2 really begins with ICESat-1. ICESat told us all kinds of cool things about the ice sheet and about sea ice that we didn't really know to ask. That data allowed us to measure elevation change of ice sheets in a way that we hadn't been able to before, and showed that all the action on the ice sheets, the places that were really changing quickly, were around the edges. So when we were thinking about what could we do better next time, we knew that was one key component.
In addition to the edges of the ice sheets, ICESat-2 needed to measure a dimension of sea ice that remained elusive: its thickness. To figure out how thick sea ice is, you can measure the height of ice sticking out of the ocean, or freeboard, and compare it to the height of water between the sea ice flows, called leads.
The problem is, sea ice is really dynamic, and those cracks open and close various places in the ice pack throughout the day, throughout the year, and what we need to do is have measurements of the ocean whenever it's available, wherever it occurs in the sea ice pack.
To solve that problem, ICESat-2 was designed with a fast-pulsing laser instrument to take precise, near-continuous measurements across its 3 pairs of beams. For 10 years, everything about the mission was designed to measure rapid changes in the most rapidly changing part of the cryosphere. But it has to get into space first.
But it's a huge transition going from the ground to in space. We've spent better part of 10 years, thousands of people have been involved, and actually seeing the rocket there on the pad with all of that work kind of all put together in one place, it's pretty amazing. And then getting up in the middle of the night to go watch the actual launch, it's sort of surreal in a way, because you've put so much time into it for so long, and actually seeing it over there is like, whoa, you know, it's a big deal.
4, 3, engine start. 2, 1, 0. Lift off. Lift 1.
Good job, Dad.
Thanks, sweetie. That was awesome. Totally cool. There it went. That was Atlas. The last Delta II, heading on up. So Atlas has been turned on over the course of the first few weeks of the mission, really culminating for us with the laser. So this is our first look at sea ice data from ICESat-2, and it looks fantastic. The signal levels look great. We've got plenty of photons there. We're capturing ridges. We can clearly see the ocean. All sorts of cool stuff in there, and this is just our first data. It's only going to get better from here on out.
The data from ICESat-2 is well on its way into digging deeper into the unknown dimensions of sea ice sheets, and glaciers. It will shed light on changes in sea level and global weather patterns, and once again find new things about ice we didn't know to ask.
So my heart is definitely racing. I don't know about anyone else's. This is the stuff nerds dream of.
Slight chance the flight may see ICESat-2 in their center windscreen. 10 seconds. 9, 8, 7, 6. That's gonna 5, 4, 3, 2,